Okay, so for the first problem, I'm converting to radians. Remember, to convert to radians, I multiply by pi over 180. I can rewrite this as 100 over 180 times pi. I want to simplify this fraction, so I can use my calculator to do so. I do 100 divided by 180. If I go back to math fraction, it turns it into 5/9. Same thing for b. I'm going to multiply by pi over 180. And I get 125 over 180 pi. I want to simplify my fraction on the calculator. Go math. Oops, nope. Math. Fraction. And it gives me 25 over 36 pi. To go from radians to degrees, I multiply by 180 over pi. The pi on the top and bottom cancels out. So then I have 720 divided by 9, which is 80 degrees. Over here, I'm going to do 180 over pi. Pi and the 180s cancel out. I just get, that should have been 13. Okay, number 3 wants me to find the arc length. Remember, the formula for arc length is S equals R theta, where theta is in radians. Okay, so my radius is 8, and I need to turn 95 into radians. (19 over 36). Okay. Then I plug into the formula, so I have S equals 8 times 19 pi over 36. It wants me to round my answer to 2 decimal places, so I multiply everything together. And I get 13.26 inches. This one gave me a unit of measure, so I want to make sure I include that. Okay. Number 4 wants me to find the area of a sector. My formula for this is A equals 1/2 r squared theta. Again, theta is in radians. My radius here is 12, and I need to turn 135 into radians. So I multiply by pi over 180. 135 divided by 180, math fraction gives me 3/4. Okay, plug into my formula. I have A equals 1/2 12 squared times 3 pi fourths. And then I want to again type this into my calculator. Which gives me 169.65 because I round. This was feet. And its area, so it's squared. Okay, so on number 5, what I want to do here is I want to find, it tells me a tire has a radius of 2 feet and it rotates at 70 revolutions per minute. It wants me to find the linear speed in feet per minute for the edge of the tire. So what I want to do is I have 70 revolutions per minute, and I want to turn this into radians, which is 2 pi radians over 1 revolution, which gives me 140 pi radians per minute. I cannot spell radians. Okay, and then I want to take this and multiply by my radius, which was 2. So I have 2 times 140 pi. which gives me 280 pi. Doesn't tell me I need to give decimals, so I leave it as a pi. Okay. Number 6 wants me to find the 6 trig functions of theta. Okay, what I want to do here is first find the missing side length. To do that, remember I'm going to use the Pythagorean theorem. A squared plus b squared equals c squared. C squared is always C is always my hypotenuse. A and b don't really matter. So I have 15 squared plus b squared equals 17 squared. 15 squared is 225. I don't know 17 squared off the top of my head. 289. Then I want to subtract 225 on both sides. I have b squared equals 64. Square root of 64 is 8. So now that I have my 3 side lengths, I can write my trig functions. I have sine of theta, which remember is opposite. Oh, let me also label these like that. I have opposite, adjacent, hypotenuse, because opposite the angle, touching the angle, hypotenuse is always the longest side. Sine is opposite over adjacent, so I have 8 over 15. Cosine is adjacent. What? No. Sine is opposite over hypotenuse. That should be 8 over 17. Cosine is adjacent over hypotenuse. That's going to be 15 over 17. And tangent is opposite over adjacent, so the 8 over 15 that I was trying to write earlier. Then we also have our 3 reciprocal functions. I have cosecant, which takes sine and flips it, so I'm going to have 17 over 8. I have secant, which flips cosine, and I'm going to have 17 over 5. And then I have cotangent, which flips tangent and turns it into 15 over 8. These are my 6 answers for this question. Okay, so what I want to do here is I want to find my key points. I don't have anything going on with my x inside, so my period here is 2 pi. I divide by 4, that gives me pi halves as my key points. So remember, I always start at 0, and then I count by pi halves. So I have 0, pi halves, pi, 3 pi halves, and 2 pi. Okay. Then what I want to do is I want to plug these in for sine. So I'm going to have sine of 0, which is 0. I probably want to label these 2. Then I have sine of pi halves, which is 1. I have sine of pi, which is 0. I have sine of pi thirds, which is -1. And I have sine of 2 pi, which is 0. So if I connect these, I have 1 period of my graph. The problem wants 2 periods, so what I do is, I noticed a lot of people on the test reflected over. That's not what you should do for this. I want to literally take this and pick it up and put it over here. So I'm starting from the 2 pi point and then working backwards. So then it's going to be -1, 0, 1, and 0. And this is what this graph looks like. Okay, so for cotangent, remember that this is between 0 and pi. Tangent is between -pi halves and pi halves. So for here, I have pi is my distance, and I want to divide by 4. Pi fourths are what I'm counting by. So I have 0, pi fourths, pi halves, 3 pi fourths, and pi as my points. But remember, 0 and pi are asymptotes on a cotangent graph. let's count by pi fourths. Pi halves, 3 pi fourths, and pi. Okay, so then I need to plug in pi fourths. Remember, when I'm doing this in the calculator, I do 1 divide, oops, not like that, parentheses 1 divided by tangent. And if I'm typing in pi fourths, I want to make sure my calculator is in radians. So I go to mode and change it to radians. Newer calculators will tell you up top. Older ones, you just have to go check in mode. Okay. This gives me -4. I'm going to do -4 cotangent pi halves. So I typed that in, -4 parentheses, oops, 1 parentheses, divided by tangent pi half. What? How did I get here? Okay, it gives me an error, but remember, if this happens on cotangent and cotangent only, this is because the calculator can't write it right to turn it into 0. If it happens on tangent, it is a 0. Okay, then I'm going to do -4 cotangent 3 pi fourths. Which gives me +4. So I'm going to go plot those points. 1, 2, 3, 4, -1, -2, -3, -4. And this one looks like this. Well, it's 2 periods, so I'm going to go and go this way. And it's going to also just copy and paste like that. Okay. On number 9, there's no change with the x. This is at the end, so it's shifting it up and down. It's the inverse function of cosine. So what I want to do is I want to graph cosine first. And I want to find my key points. So it's going to be 2 pi divided by 4. I have 0, pi halves, pi, 3 pi halves, and 2 pi. Sorry. Okay, so then I'm going to graph my cosine. I have cosine of 0 minus 1, which is going to be 0. Pi halves, pi, 3 pi halves, 2 pi. I'm going to have cosine pi halves minus 1. That one I don't know off the top of my head. Oh, nope, I hit the wrong button. If I'm typing in the calculator, I'm going to remember to close after my angle and then do the -1. Otherwise, it doesn't calculate the angle right. So it gives me -1. I have cosine, I'm just going to do these all while I have the calculator here. Pi minus 1. Just -2. I have cosine 3 pi halves minus 1. Which gives me -1. And then I should have cosine 2 pi minus 1. Which gives me 0. Okay, it's going to want... That doesn't look right at all. I missed half my points. That's curvy. This one is going to want 2 periods as well, so I'm going to go and copy this over. I'm starting at the 2 pi and then going down, so I have -1, -2, -1, 0. Remember, the way we do our asymptotes is we do it in between the peaks and the valleys. So I'm going to have an asymptote at pi halves and an asymptote at 3 pi halves. negative pi halves, negative 3 pi halves. Then where I have a peak, it curves up. And where I have a valley, it curves down. And I just go ahead and draw those all in. Okay. Number 10 wants me to use a calculator to find the value in degrees of inverse cosine of 4/5. So to do that, I go second, press the cosine button, 4 divided by 5. It gives me, it wants 4 decimal places, 0.6435. Okay. Number 11 wants me to use Drimonov's theorem to find the indicated power. Remember, this one is on the very bottom of the reference sheet I'll be giving you. What we do is we take our exponent, we give it to the radius, and then we multiply by cosine, and then we also take the exponent and multiply by the angle, plus I sine the exponent times the angle for sine. So my exponent here is 6, so I have 2 to the 6 cosine 6 times 10 plus I sine 6 times 10. 2 to the 6 is, nope, I typed that in wrong, 64. Then I have cosine 60 plus I sine 60. I want to distribute my 64. So I'm going to have 64 cosine 60 plus 64 I sine 60. I want to evaluate these functions at 60 degrees. Cosine at 60 degrees is 1/2. Sine at 60 degrees is square root of 3 over 2. Then I just want to multiply and simplify. So 64 times 1/2 is 32. 64i times square root of 3 over 2. I just divide the 64 by 2 and I get 32i square root of 3. Okay. This one wants me to verify the identity. I'm gonna work on the left side because there's more to work with. So I'm gonna rewrite the cosecant and secant so they turn into sines and cosines. So I have sine of theta over 1 over sine of theta plus cosine theta over 1 over cosine theta still equals 1. Remember, this is the same thing as saying sine over 1, so I'm going to rewrite it as sine theta times sine theta over 1. And then, because I want to flip my fraction to multiply, I'm going to do the same thing for cosine. Equals 1. Then I have sine squared theta plus cosine squared theta equals 1. That is that's a Pythagorean identity. I end up with 1 equals 1. Okay, number 13 wants me to verify this identity. Because I see a minus sign, I'm going to use the difference formula for tangent. That's also right here on my reference formula. So I'm going to have tangent 2 pi minus tangent x over 1 plus tangent 2 pi tangent x, and this will equal negative tan. Then what I want to make that clearer that that's negative tan and not a really long t. Okay. Then what I want to do is evaluate where I have tan of 2 pi. Which is 0. So I have 0 minus tangent x over 1 plus 0 times tangent x. Oops, I forgot my x over here because I was focused on that. Okay. Anything was 0, so I'm just going to have negative tangent x over 1 because 0 times tangent is 0 equals negative tangent x. Negative tangent x equals negative tangent x. Okay, number 14 wants me to solve the equation sine equals 3x equals 1 on the interval 0 to 2 pi. What I do here is sine is 1 at pi halves. So I have 3x equals pi halves plus 2 pi n. And then I want to divide by 3. To get my x alone, I get x equals pi 6 plus 2 pi thirds n. So pi 6 is going to be one of my answers. What I want to do is I want to make sure that this is under 2 pi. Remember, 2 pi, if we're talking in 6, is 12 pi 6. So I am going to plug in values for n to check. So I have, if I'm testing n equals 1, it's going to be pi 6 plus 2 pi thirds. To turn that into 6, I need to multiply by 2 over 2, which gets me pi 6 plus 4 pi 6, 5 pi 6, still under the 12 pi 6. Then I'm going to do the same thing for n equals 2. I have pi 6 plus 2 pi thirds times 2, which gives me pi 6 plus 4 pi thirds. I need to turn that into 6, so I'm going to multiply by 2 over 2. Gives me pi 6 plus 8 pi 6. 9 pi 6 is still less than 12 pi. Okay, then I'm going to do it for n equals 3. I have pi 6 plus 2 pi thirds times 3, which gives me pi 6 plus 2 pi. This one needs to be multiplied by 6 over 6, which gives me pi 6 plus 12 pi 6 equals 13 pi 6. That's more than I wanted, so only these values are my answer. Okay, number 15 wants me to solve the triangle, so I'm going to go ahead and draw it. Okay, I am missing an angle, so I'm going to search for that first. I have 180, it's A that I'm looking for, 180 minus 125 minus 5 equals 50. So I have A equals 50 degrees. Then, now that I have that, I can use my law of sines to search for my missing side lengths. I have 200 sine of 5 equals, we'll do C first, C over sine of 125. I want to multiply both sides by sine over 125 to get it alone. I have 200 sine of 125 over sine of 5 equals C. When I type in my angle for 125, I want to close the parentheses. And I also, remember I was using radians earlier, I want to change my mode back 2 degrees. I don't think I hit enter. Okay, now that I'm back in degrees, I accidentally put plus instead of 200. Okay, C is 1879 points. This one's to 1. Then I'm going to do the same thing for my A side length. So I have 200 sine of 5 equals A over sine of 50. I multiply both sides by sine of 50 to get A alone. So I have 200 sine of 50 divided by sine of 5 equals A. And I'm going to type that into the calculator. And I get 1757.9. This one rounds. Number 16 wants me to decide if this gives me one triangle, two triangles, or no triangle. And then if it gives me one or two to solve it. So I am going to start by drawing. Okay. I am going to use the law of sines to see if I can find my angle for B. So I have 7 sine of 12 equals 28 sine of B. I want to cross multiply since my B is my angle. I have 7 sine of B equals 28 sine of 12. I want to get the sine of B alone, so I divide both sides by 7. I have sine of B equals 28 sine of 12 divided by 7. To get rid of the sine, I need to multiply by the sine inverse. So I have B equals sine inverse 28 sine of 12 over 7. Which gives me, this one wants it to round to the nearest whole number, 56 degrees for B. What I need to do is I need to check to see if my second B value works. So B of B2, I have to do 180 minus 56, which gives me 124. I want to see if 124 plus 12 is less than 180. It's 136, which is less than 180, so my second B value also works. So I have B1 is 56, and B2 is 124. So I'm going to go ahead and solve for my first triangle, and then I'll move on to the second triangle and solve for that. So on my first triangle, I know this is 56 degrees. I want to go solve for that missing C value. So I'm going to have 180 minus 12 minus 56, which gives me 112 for this C value. Okay. Then I want to use law of sines to find the length. So I'm going to have 7 sine of 12 equals C sine of 112. I multiply both sides by sine of 112 to get C alone. And then I want to type that into the calculator. This gives me a side length, so this is 31.2. Okay. Then I'm going to go do the same thing for my C2. So I'll draw this triangle over here. This B value was 124. And then I need to find this C2 value. So I'm going to do 180 minus 12 minus 124. Which gives me 44. And then I want to do law of sines to find the side length for C2 right here. So I have 7 over sine 12 equals C2 over sine of 44. I want to multiply both sides by sine of 44 to get that alone. So I have C2 equals 7 sine 44 sine of 12. I want to type that into the calculator. And this gives me 23.4. So those are all my links. And remember, if I forgot the law of sines, this is also on the formula sheet. Forgot to mention that. Law of cosines is right here. I'll be using that for the final problem. So what I want to do is I'm going to draw out my triangle. These are all side links, so that's how I know I want to use law of sines. Okay. So when you're using law of sines, you have all side links, you want to take the largest side and have that as your value that's squared on the left. Then I have 25 squared plus 45 squared minus 2 times 25 times 45 cosine A. What I want to do now is I want to find my values so I can, or simplify so I can find my value of cosine A. 66 squared is 4,356. 25 squared is 625. 45 squared is 2025. Negative 2 times 45 times 25 is negative 2250 cosine A. Okay. Then I want to combine like terms. Do not combine this one because it's attached to the cosine. 625 plus 2025 is 2650. Divide the 2650 on both, or subtract the 2650 on both sides. Get 1706 on the left equals negative 2250 cosine A. Then I want to divide by the negative 2250. So that gets me cosine A equals 1706 divided by negative 2250. I want to find my cosine inverse. What am I doing? So I have A equals cosine inverse 1706 over negative 2250. And this is what I'm going to type into my calculator. And I get 139 point, this one's an angle, just kidding, 139 for my A value. Okay, now that I have an angle, I can use the law of sines. So I have 66 sine of 139 equals, we'll do B, 25 cosine B. I cross multiply to get cosine out of a fraction. Okay, I have that. Then I want to divide both sides by 66. I get cosine, this is sine. Why did I write cosine? Okay, so I end up with sine B equals 25 sine 139 divided by 66. I want to do my inverse sine. Which I'm going to write down here. B equals sine inverse 25 sine 139 divided by 66. So I'm going to figure out what B, what B is. B is going to be 14. And then because I was really bad at spacing, I'm going to solve for C in this corner over here. I have 180 minus 139 minus 14. Gives me 27.